Okay, welcome Genevieve and Stephanie and Heather and Braulio. Thanks for coming.
Hi.
And this is our penultimate webinar. You know what penultimate means? Second to last. So this is a webinar, and it's a really valuable one, useful one. And let me share my desktop. And we'll talk about the plan and what it's all about. Okay, so the plan today is I'll answer any questions that you might have. And then we're going to get into scatter plots and correlation. And also the regression line too, just by looking at it. So it turns out that regression analysis, which is what we're doing today, is a big, big, big deal. It's used in lots and lots of situations. And unlike what we did last week, it's used in like general presentations instead of only publications. Does that make sense? So it doesn't have to be a journal. But regression analysis is used in a lot of places, including journals. We'll look at R squared and interpret that. That's the shortest thing, at least in symbols, on the list of things to do. And it's the hardest thing, just let you know that. It's the thing that most people have the most trouble with, and hopefully you'll get it by the end. I'll have a couple examples and we'll play around. We'll talk about the linear regression line. And let's see if you remember some beginning algebra. If you're talking about a equation of a line, what two numbers do you need? The what and the what? Two words. Who remembers? So if you have a line, y equals something, something, then you have two important numbers. Anyone recall it? See y'all jumping in. No one remembers? Slope and y-intercept, does that ring a bell? Maybe. But we'll talk about the slope and y-intercept and how to interpret the slope and y-intercept of a line, and in particular a regression line. And then, because it is statistics, we're going to be doing a hypothesis test. And we'll be doing a hypothesis test for correlation. So that's the plan of today. And I want to let you know that I am, I wouldn't say in the middle, but towards the beginning of grading projects. I first wanted to make sure I graded your discussion posts. That takes some hours. And then I moved to the projects. So I'm partway through the projects, and I'll grade some more tomorrow. I'll definitely be done in the next few days. So by Thursday for sure I'll be done. Maybe Wednesday is to be done. The only reason why I would get hung up, any guess? Why I could just stop doing anything? With
Weather?
Yeah, weather, because we're having a storm tomorrow. So I want to let you know ahead of time that if I don't show up to office hours, that means that I have no internet. Okay, so far so good. Or let's hope this doesn't happen. 15 minutes from now, all of a sudden this gets turned off. That's why, because we do have some weather happening here. So let's hope the internet stays. But you know how internet is, so you never know what's going to happen when you're doing things that are important. So far this quarter, we haven't had any problems, right? I don't think we've lost internet at all. But we do have weather coming right now and tomorrow. So just know, and Wednesday too. So I figure I'd give you a little warning about it. So again, I'm reading the projects, and I grade them as I go. And it's your last project, so I'm not going to talk about how you can do the next project because there isn't one. So it is what it is. But there's lots of comments, and I want to remind you that make sure that if you're the person that posted your project, make sure that you share the comments I wrote to your partners, because only the person who posted it can see the comments. So share, and then you can share with them. I wish Canvas worked a little better with that kind of thing, but it doesn't. I can't post it to multiple people. I can only post it individually. So sorry about that. And I mean the comments directly on the paper. The comments that I put on the sidebar, that everyone gets. That I can do. I can copy and paste them in. But the ones that are directly in your paper because they didn't submit the paper. So that's just a note about the project. And another thing is we're getting towards the end. So I figure I should like give you a reminder. What happens in 2 weeks? Ish.
Finals?
Yeah, final exam. So the final exam is in kind of 2 weeks. So 13 days, 15 days, and 16 days. So just like the midterm exams, I let you choose between 3 different days. This time it's Sunday, Tuesday, and Wednesday. So those are the days. So I can't do it later because I have to grade the exams and turn them into the college in time and stuff. So that's why Wednesday's their last day. So just note that those are the choices to take the exam, and there's times. You can look it up. I don't remember them by heart, but I figure I'll make the announcement. I'll talk a lot more about it next week. So are there any questions about anything? Feel free. Webinars are a great time to ask questions. I don't see any questions. Okay, I have a question for you, especially for those of you who are in Tahoe or lived in Tahoe. And again, I don't remember who lives where, sorry. But what is the most important data that is collected by far in Tahoe? Those who live in Tahoe probably know. Snowpack's important, but not the most important. Snowpack's important in a lot of places. This is just here. That's the hint. So Mammoth wouldn't do this. Everyone think about snow because it's winter time, but no, this is done all year. Okay, especially summer actually, but all year. So what do we care about Tahoe? What do the scientists care about? Do we have anyone who lives here? If you live here, you better know. Yeah, the Blue Lake. Okay, good. Somebody knows. Yeah, we care about the Blue Lake. And water level actually isn't that important. We have a dam and that's regulated and stuff. You may not know about that. But it might be what you're thinking. It's water clarity is the big thing in Tahoe. So if you're not from Tahoe, just trust me. And what they do is every year they take what's called a seki disc, which basically is a little white plate, and they tie it to a string. They drop it down and they look to see how far it goes down before they can't see it anymore. And then they measure how far, and that's the depth of clarity. Does that make sense? And one of the cool things is I got to talk to the researchers. UC Davis is where they do the research. I mean, where they do the research in Tahoe, but the people who do the research are UC Davis scientists. And I asked him, you know, when you do these samples, how many days do you go out and test it? Any guess on what they told me? The hint is I smiled. Any guess? How many days do you think they test for clarity during the year, each year?
So one of the numbers that we always talk about, like 30?
Yeah, but 31, remember?
1.
30 is not high enough. 31. That's why I smiled. He actually told me that. It's like, and I didn't like push it at him. You know, I asked him how many days and he said 31. I just started smiling because that means he's doing it right. Okay. I think now it's a she actually, but it's a group. So what they do is they measure the water clarity for 31 days. They take the average of those 31 days and they call that the year's clarity level. Okay. Depth of clarity. Okay. And as you should all know now, is that because they take an average of 31 days throughout the year, that means that you can assume that you have a normal distribution. Isn't that nice? So then what they do is every year they do that and they plot it. And now I'll tell you a really cool story. One of my students told me about this. One of my statistics students was at dinner with the most important person in the world at the time. And you guess who that person might have been? Not the name, but their position. It's not a math question. Yeah, the president of the United States. And this was a long time ago. This was President Clinton. Okay. But I wanted to kind of show you what it looked like. And what they did, what the UC Davis scientists did, is they came to the diner that President Clinton was eating at, and they presented the following pictures. And one of the good news about Clinton, which again, if you're young, you probably don't know its history, but Clinton actually understood statistics, which in my feeling that I think that should be a requirement for president. I think that's a good thing because then they understand like who's trying to fool them versus who's giving them real data. And they were able to show this picture. Okay. So if you look at this, you see what's called a scatter plot. And we've briefly talked about scatter plots, but the hard part for y'all is that was in early January at the beginning of our class, if you remember, maybe January 10th or something like that. But we talked about scatter plots. It was one of the types of graphs or plots that you can do with data. And you do a scatter plot when you have two quantitative variables. So in this case, the two variables are date, the year, and the year is definitely quantitative, and the depth of clarity in meters. Any questions on what a scatter plot shows? Any questions? Okay, now here's a tough little question. If you kind of imagine like the best line that would kind of go through these points, you can't find a line that goes through all of them, but kind of the line that is the best fit is what we call it. Do you think it has a positive slope or a negative slope? What do you think? What's your idea? It's not true. So is it a positive or negative slope? What do you think? Type it in the chat box, say it, whatever you want to do. Okay. Well, at least a couple people answering. Okay, so the bad news is this is a total trick question, and I would never do this to you on a test. Actually, it has a negative slope, and this is why it's a trick question. Look at the y-axis. It's upside down. Because if you look at depth, you go down for more depth, right? Yeah, so that's a trick question. That's mean. I would never give that to you on a test. I would never give, even on a homework problem, I wouldn't give it to you. But I thought, it's called real life, right? Okay, and I didn't do this as a trick question. Yeah, probably I was kind of tricking you into it. But I gave it because this is like, to us, those who live in Tahoe, this is the most important thing that there is when it comes to data for our lake is what we were so proud of. Do y'all agree? Those who live in Tahoe. Okay, snow's important, but lots of people have snow, but no one has Lake Tahoe except us. So this actually has a negative slope. And do you have to, when you look at these points, do they all lie on a line? Do they lie on a line? Is this a linear group of points? What do you think? Okay, pretty much is not the same thing as yes. Okay, the answer is no. There is no line that hits all these points. You can try all you want. You're never going to get a single line that hits all the points. Okay, so that's the first thing, is they don't lie on a line. So what you want is, because in the real world, very few things lie on a perfect line. But what you can do is you can imagine if you drew a line that was as good as you could get, do you have to use your imagination a lot, or is it kind of clear, like how you would visualize a line, and that the points wouldn't be that far from the line when you drew this line? Can you all visualize a line? And they kind of drew kind of a line. Again, I got this from the UC Davis website. You can all visualize this blue line. And the points aren't that far from the line. So to talk about whether the points are far from a line or close to a line, there's a number that we associate with that. Okay, and that number is called the correlation. And that number does a little more than that. It also tells you whether the line is a positive slope or negative slope. So if it's a positive slope, then we're going to use a positive number for the correlation. And if it's a negative slope, we're going to use a negative number for the correlation. Oh, did I? Let's see. Oh, yeah, good. Just want to make sure I recorded. I always, that's my nightmare, is forgetting. Yeah, it says recording. Okay, so in this case, again, this is a tricky one, but this is a negative slope line because the y-axis is upside down. So you got to turn your head upside down, and then you'll see it being positive. So the correlation is going to be positive. Now it turns out that if we look at this number correlation, let's write this down. Correlation is between -1 and 1. Okay, so what I'm not going to do in this class for y'all is get into the mathematics of this. And trust me, you should smile about that statement, because most of you it wouldn't work. It's really brutal mathematics. So I'm not going to do the mathematics of the correlation. But I want to do is give you an idea of the number, and you need to understand the idea of the number. So first thing, you can never have a correlation of 3. It makes no sense. You can't have a correlation of -4. Okay, you can have a correlation of, say, 0.6. That works. Okay, if the correlation is 0, then the line is a horrible fit. So the example that you all know, unless you live in New York City or something, is the night sky. That's not in New York City, by the way. the Tahoe night sky, probably the Modesto night sky. If you look up in the night sky and you look at the stars, do you see a line? What do you think? Do the stars look like they're all kind of close to a line? Not at all. They're all over the place, right? Okay, you look up there and there's a bunch of dots all over the place. So the correlation of the night sky is pretty close to 0. Okay, it might be 0.01 or something, or -0.02, but it's going to be really close to 0. Does that make sense? If the correlation is close to -1, then the points all cluster near a negatively sloped line. Okay, so in this case, the correlation is probably close to -1. Again, you have to turn this upside down. So that's always a kind of a pain for this particular example. But so this one is probably going to be like negative 0.9 if you looked at the correlation for this scatter plot. Okay. And then kind of the other side is that if the correlation is close to 1, then the points all cluster near a positively sloped line. Any questions on kind of these ideas? Okay, and then one thing, the letter we use for correlation is R. Sorry, it's not C. Don't get mad at me for this one. I think R for regression. I think that's why they use R. I'm not 100% sure, but that's my guess. Maybe they like that there were 2 R's in correlation. I don't know. But everyone in the world uses R for correlation. Any questions at all on this idea? Okay, so that's the correlation. So I'm going to give you kind of some thoughts and see if you can tell me what the correlation might be. What if you looked at, let's say you went to an elementary school and you looked at the weight of a child in elementary school and the height of the child in elementary school. And you plotted the scatter plot. What do you think the correlation might be? What's your guess as a number for R? If it was weight on the x-axis, height on the y-axis in an elementary school for students. What's your guess? And remember, there's kindergartners, there's 5th graders, 3rd graders, etc. So either pop in the chat box, say it. What's your guess for the correlation of weight versus height in an elementary school as a guess?
I would think that the elementary school would be closer to 1.
So what number?
Closer to a positive 1, right? Because
So give me a number.
Up.
It's a guess. Just give me a guess. Specific.
I'm not sure about that.
Just give me a number.
0.7.
Okay. Okay. 0.7 is a good guess. Okay. And again, I don't know for sure what it is. I would probably guess more like 0.9 actually. And that's because in elementary school, as you get older, you get heavier. Okay. But not all tall people are heavy. But I'll tell you, the 5th graders are both taller and heavier than the kindergartners. Pretty much all of them. Does that make sense? So that's why, it's pretty standard. Now it's not 0.999 because there are, some, slightly overweight 3rd graders, for example, that may not be very tall, but it's pretty clear. This one, if it's like really obvious that it's going to happen, then it's more like 0.9 something. Does that make sense? Okay. How about if I asked you, how many hours students log in to Braulio's office hours and their GPA? What do you think the correlation would be there?
I would hope a high number since I spend quite a bit of time with Braulio.
Mm-hmm.
0.6.
It'd probably be a high number. I don't think it'd be 0.9 though. But then
0.6.
I would guess it's definitely positive because people who, spend more time with Braulio definitely, tend to do better. But not everyone spends time with Braulio. You know how that it works. Sorry, Braulio. but it definitely would be a positive correlation. Okay. How about something like the temperature, the high temperature in Lake Tahoe on a certain day, and the high temperature in New Zealand by day? Okay, I don't even know. Give me a city in New Zealand. I'm not a great geographer. Capital New Zealand, whatever that might be. But I picked New Zealand on purpose. So what do you think the correlation might be there? Any ideas?
I don't think there would be any correlation. So probably like 0.
Okay, why do you think it'd be 0?
And I'm just trying to think of like our location and New Zealand's location. I just don't know if there's any similar, like, I don't know. I just can't see how.
Okay, if you did it for this month, it would probably be 0 or close to 0. But if you did it for the year, it wouldn't. It would be probably about -0.6. Because what's special about New Zealand? Where is New Zealand? It's on near the South Pole, right? So our winters are their summers are our winters. So if it's warmer here, it's more likely to be colder there, and vice versa. Does that make sense? If I said our sun, no, so if I said our high temperature in Tahoe, okay, and maybe the high temperature in Ecuador, then you might have a 0. Because I don't think Ecuador even has seasons, temperature seasons, because it's on the equator. Does that make sense? So that might be close to 0. Does that make sense? Okay, but if our summers are their winters and their winters are our summers, then you're definitely going to see a negative correlation. Hot in Tahoe is more likely to be cold in New Zealand. Any questions on that idea? Okay, so that's what correlation does. So now let's something that hopefully you all know is we can look at a line, and I'm going to annotate the line. Whoops, sorry. Let's try again. I'm not very good at drawing a line on the computer. Okay, so that's a pretty close to a line. All right, so that's my annotation of the line. So how do we find the equation of this line? Basic algebra. I'll start out, because remember I told you there are 2 important numbers of a line, the slope and the y-intercept. Let's start with the y-intercept. What's the y-intercept of this line?
Would it be like 25?
Definitely not 25. Actually, the y-intercept would be kind of tough on this one. Yeah, that's too hard a question. What I'm going to do is I'm going to call it the y-intercept, but I'm going to tell you what x is. X is not going to be the year. So let's write this out. Otherwise, it's too hard. Let x be the number of years since 1965. Okay, because if you do the year, the y-intercept is meaningless. How come?
Oh, because it just started at 1965.
Yeah, but if you just
previous
did the
stuff.
pure year, then how many people were there in Tahoe in the year 0? Year-round residents, for example? Year-round residents, we do know. Zero. No one lived here. No one could live here. You didn't have the technology to live in the cold, and no food and all that. Yeah, there were no people in Tahoe in the year zero. There were in the year 1965 though. So there's no way to do the data. The data is kind of meaningless because there's no effect of people for like the first 1500 years or maybe 1900 years actually. So you wouldn't even talk about regression analysis considering like the year zero. So you wouldn't even go there. So if I asked you about a y-intercept and we did y was the year, then you would say it's meaningless. You could find it, but it would be meaningless. Does that make sense? But if I did since 1965, now it has some meaning. So what was the y-intercept in 1965? Right? That's the year zero. That's the zero in my new scale here. That's right here. What's the y-intercept? About 30. I think it's more like 31. Do you see? A little below 30. So I'm going to say it's 31. So then the y-intercept is 31. Any questions on eyeballing the y-intercept? Now, the y-intercept by definition is when x is 0. Now, x is a number of years since 1965. So that if it's 0 years since 1965, that means it's 1965. So the interpretation of the y-intercept is the following. That our best prediction for the depth of clarity in 1965, that's 0 years after 1965, is 31 meters. Any questions on interpreting the y-intercept? Do you think you're going to be asked to interpret the y-intercept? Like on the final exam? What do you think?
Yes.
Yeah, guaranteed. Okay. And in fact, the question will say, interpret the y-intercept or explain why the y-intercept is not relevant. So if the question were X is the year since 1965, then that would be the sentence you write, what I just wrote. If on the other hand, X was the year, then you would say it's not relevant because the year 0 is not relevant for this diagram. Okay. And in fact, if you're away from most of the data points, if you're really far away, then you don't interpret the y-intercept. It's too far to care about it. You could find it, but not interpret it. On the other hand, whenever you have a regression analysis, when you have a correlation that is not that close to 0, the slope always has meaning. So first, let's find the slope. So how do we find the slope of a line? Who remembers the algebra way of finding the slope of a line? Kind of 3 words that you learn in probably middle school. Okay, y equals mx plus b is the equation of the line. And if you remember, m is a slope, but how do you find the slope? How do you find m? We found b already. That was our 31. But how do we find the slope? How do we find m? And it's 3 words, not equations, words. And you all know it. Doesn't mean you remember it, but it wasn't some mysterious thing. You got hammered it when you were in school. Yeah, rise over run. Okay, so we look at the rise over the run. So I'm just going to go from kind of beginning to, how about 1965 to 1995? That's as far as I can go with a good number here. Okay, so notice that we are rising from 31 to, and if we look at 1995, that looks like about 21. Do you see that? So the rise is going to be 31 minus 21. That's the rise. You subtract.
Can you tell me how you got that again?
Okay, so 31 is the y coordinate of this first point. And 21 is the y coordinate of this last point.
Okay.
Okay, and I'm eyeballing it. You know, is it perfect? No, but I'm eyeballing it. Okay, how about the run? So there's the rise, and we divide by the run. So how much does it run? That's the change in x. How much do you change in x from 1965 to 1995?
30 years?
Yeah, 30 years. And I'm going to write 1995 minus 1965, just so we can see it. But it's also 30 minus 0 because our x is how far from 1965. Okay, and if I do that, I could do that pretty easily. 31 minus 21 is 10. And we said the bottom was 30. 10 over 30 is 1/3. Any questions on that?
Can you scroll up a little bit, please?
Yeah, the only problem with scrolling up, there's a reason why I didn't, is
don't-
the line goes away. So I scroll up, but then you're gonna lose the line. But you can still see the blue kind of curvy line. But now let me get that line I drew. That would be annotate, clear all. There we go. Okay. All right, so now we have the slope of the line, which is 1/3. And I'm going to write that in decimal form. It's usually a little better to write in decimal form, which is 0.33 approximately. And write over 1. Can always write over 1. That's a math thing, right? Divided by 1 never changes anything. Any questions so far? So now let's interpret interpretation of the slope. Now remember, the slope is a rise or a run. The rise is a change in y, which is a change in the number of meters. Oh, you know what this is? Negative, sorry. It was 31 minus 21, 1965 over 1995. I knew I made one mistake. Sorry about that. So that's 10 over, it's negative 10 over 30, which is negative 1/3, which is negative 0.33 over 1. So it's the rise or a run. I'm going to write that down. The rise is a change in y over the run, which is a change in x. The change in y is the change in depth of clarity in meters. And the change in x is the years past. Any questions so far? Okay, now notice that the denominator, when I write it this way, is 1. So that means 1 year passing. So I can write for every year. That's 1 year.
Bájale eso, Kingston.
It goes by. The clarity tends to decrease by 0.33 meters. Okay. And by the way, when you have negative, they usually use words to describe negative because it sounds weird to say, well, the clarity increased by negative 0.33 meters. That sounds weird, doesn't it? So it sounds a lot better to say it decreased by 0.33, which is the same thing as a negative increase. Anyone lost on this interpretation? All right, here's the harder part. Would you be able to do it now that you've seen an example? Would you be able to do it with a different example? Kind of with the same steps because you're going to be responsible for it. So just let you know, don't just watch me and just hope it's going to be gone because you're going to have to do it. Okay, on the final exam, by the way. Okay, and the homework this week and the discussion post this week. So just to note is that you have to be able to do this. Any questions at all so far on the idea of regression analysis? Okay, now let's do the equation, y equals mx plus b. So note that the equation, you know what, let's see. There we go. So the equation is the following. So let me insert equation. Okay, so the first thing is you tend to write y hat for your predicted y. So you put a little hat on top, and that means that your best prediction for y. And y hat equals mx plus b, which is negative 0.33 x plus b, which was 31. Any questions on this? Any questions? Okay, so now let me get back to the story. So imagine, President Clinton sitting there, listening to these scientists. Unfortunately, he understood science. I think that's a good thing. And let's suppose that he asked the question, what's the depth of clarity going to be like in the year 2020? How about 2021, since we're there now? So what is the predicted depth of clarity in the year 2021? Okay, and by the way, 2021 is what, 50, let's see, that's 35, 45, 55, 56 years after 1965. Any questions on that? How do we do it? The hint is this is much easier than what we've already done. So what do we do?
You plug in for X, right?
Yep, and that's it. So we go negative 0.33. I lost a negative. How did I put a negative? So negative 0.33 times 56 plus 31. Okay, and by the way, that is like far into the future. For him, not for us. And what do you get? Zoom is keeping everything away. There we go. 12.52. right, is that okay, by the way? Would it be okay to now have a clarity of 12.5 meters? Those who live in Tahoe, by the way. Those who don't live in Tahoe may not care. What do you think?
It seems wrong just because it seems like we could see a lot further down than 12.5 meters.
Right, but here's what happened. Let me give you the story. Okay, the story is this was a prediction that if things go as they are, as they were going, that this was what would happen in the year 2021. That's a disaster. Lake Tahoe would have been murky. It would have smelled bad. It just would have been gross. Okay, it just wouldn't even be a blue lake anymore. It would be like green Lake Tahoe. Okay, so it would be horrible. So the good news, as I mentioned, is Clinton actually understood statistics. And what do you think he did? Any guess? This is history. Okay, he passed a law. And he acquired amazing amount of funding to make sure that this didn't happen. Okay, literally over $100 million on working to do everything that we could do to keep all of the human waste out of the lake, to keep this from happening. Okay, on the other hand, had Clinton not been, like I said, not understood science and not understood statistics, we'd have a lake that was murky and horrible. But because our president at the time truly understood regression analysis, he said, I get it, and we got to do something about it. So let me tell you the good news is after the law was passed, which was around the year 2000-ish, here's the rest of the story. So now we can see what Lake Tahoe has done since. What do you notice if you look from 1995 to today? Now, what do you notice about the regression line? If you ignore the stuff before 1995 and now do the kind of more recent data, what do you see?
It looks like it's cleaning up a little bit.
Cleaning up a little bit,
more
but it's
recent.
definitely not continuing up on the regression line that we were doing before. Do you see that? So it's cleaning up, and you'll also notice it's not like it just stopped going up or down, but it went way down, then it went way up, right? I guess this is way up, and then way down, and then way up, and then way down. Do you see that? Okay. And the idea here is that even though we were able to stop the human issue, okay, which is what was making this regression line have the negative slope, that doesn't mean we can stop nature. So there's other stuff that was affecting lake clarity besides humans. But the other stuff didn't have a trend over the years. Sometimes it made it go up, sometimes it made it go down. Does that make sense? So now comes what we call R squared. Oops. So that's over here. So our R, we guessed, and we're going to use the guess. It looked like the R was around, 0.9. So let's use 0.9. And the good news is that there's nothing tricky about this. Any guess on what R squared is? If R is 0.9?
0.81.
I think someone said. Yeah, 0.81. 0.81. So let's put that in. So I'm going to write an equation so we can write R squared. They usually use capital for some reason. R squared equals 0.81. Any questions on that? And typically with R squared, you want to use 2 decimal places, and I'll show you why. So let me talk about the interpretation of R squared. So we could see that if you look at kind of what humans were doing, and that's kind of the trend over time, there's definitely a trend over time. Okay? But even if humans aren't around, lake clarity still goes up and down. Does that make sense? So if you kind of fix a little time period, it'll still go up and down, but not as much. It won't have the range or the standard deviation that you have to look at all the points. So if you look at all of the data and kind of ignore the x-axis and just look at the data for the y value, then it's going to have a pretty big standard deviation. Do you see that? Because it fluctuates all the way from over here, which looks like around 19 to 31. Do you see that? And that's a big fluctuation. But if you kind of focus around just any particular, close years, it's only going to fluctuate a few meters. Does that make sense? So the idea is that there's a lot of variation in these data values if you ignore the year. But if you focus on a year or a kind of a period of close by years, then that variation is going to be reduced. Okay, and we could say the standard deviation will be reduced. So now let's write that down in words. We can say that there is a large standard deviation in the lake clarity or depth of lake clarity. But if we just focus on a few nearby years, then the standard deviation, also sometimes called the variation, in the depths of clarity, will be reduced on average by 81%. So another way of saying is that 81% of the variation can be explained by the year that you're looking at. That's human caused. Whereas 19% of the variation is due to other causes. Okay, and anyone know, this is not a math question, anyone know the number 2 cause of variation in lake clarity? Any guess? Those in Tahoe might know. Number 1 is humans. Anyone know? Don't see y'all jumping in. No, boats are humans. That's people.
Say our snowfall, right? Like
yeah,
our
snowfall. Yeah, precipitation. Yeah, precipitation and rain also. If there's a lot of precipitation, then you get a lot of runoff, and runoff is going to hurt the lake. Okay, but again, that's going to go up and down just because it does. We can't do anything about that. But we can do things about the boats and the cars and trash and all the bad things that we put in the lake. Okay, we can't do anything about the fact that some years we get a lot of snow and some years we don't get much snow. Okay, so that's just a note, is that, but 81% was human caused. So we were able to reduce that human caused issue significantly after Clinton, and now almost all of our variation is due to weather, whereas before it was human. Most of it was human. Any questions on this idea? One more thing which I didn't do and I should do is when I calculated the predicted depth of clarity, I want to emphasize something. And that is the word predicted. So let me write this one more time, is the best prediction for depth of clarity as each year goes by. Oh, sorry, in 2021 is 12.52 meters. Okay, in those days before we actually did something about it. Any questions at all on this idea? Okay, so I want to mention some really important things. One is words that you should never, ever use in this chapter. One is cause. Okay, let me write this down. Do not use the words cause. And then another one that comes from this, because. Kind of will is a bad word. So it will be this. Instead, you say it's predicted to be this. So there's a lot of words that you got to avoid. You should never use words that talk about cause or absolute knowledge of. Any questions on that idea? And if you do, what's going to happen on the final? Yeah, you will lose points. Okay. And I will give you the opportunity to not lose points. Let's put it that way. So don't make that mistake. I'm going to talk more and more about the final as we go because it's coming up soon. Any questions on kind of the way you talk about this thing? Okay. And in our class, but pretty much for almost everything we've done, we never have cause and effect. Okay. It's very difficult to do statistics and be able to say you have cause and effect based on the data. Okay. All we can do is we can say we have a trend, we have a prediction, we've noticed that as this goes up, this tends to go up. That you can do, but you can't do cause and effect. Any questions on that? Okay. So does that mean cause and effect in the world can never be determined? What do you think? So for example, if you look at how many cigarettes someone smokes and how long they're expected to live. With data, will that give you cause and effect? By looking at a regression line with that? What do you think? Based on data, looking at how long people live versus how many cigarettes they smoked in their lives, and you end up with a negatively sloped line, more cigarettes, less lifespan. And you look at that, and that's what you got. Can you establish cause and effect from that regression line? What do you think? Can you look at the regression line and say, you smoke, that's going to cause you to die? Can you? I'm waiting.
I think with the smoking and dying, there is cause and effect there because they put warning labels on cigarette packages and cancer warnings.
Okay, so here's how it works. If all you have done is looked at the regression line, you cannot say it's cause and effect. So here's how it works in the world. You look at the regression line, you see the negative slope. You don't do cause and effect right then. Then what you do is you talk to biologists. And you say, can you go study what's happening in the lungs when people smoke? And then the biologists go and say, oh, wow, we didn't know this. because, I'm talking about like in the 50s or whatever. But because of the statistics, a red flag got put up, not cause and effect, but a red flag to see if there might be cause and effect. Doesn't mean there is. So then the biologists go and say, look what these cigarettes are doing to the lungs. Do you see that? And then people are dying. Okay, it's a collaboration between statisticians and scientists. The statisticians give the scientists something to study to see if there's a cause and effect. Without the statisticians, the scientists might not even think about looking. Then the scientists go in and study it, whether it's biology or chemistry or whatever, and then they've come up with the biological reason why it's happening. And then you have cause and effect. Do you see how that works? The statistics does not give you cause and effect. The biology does. Okay. And by the way, cigarette smoking is really bad for your health. Hopefully you all know that, but not only because of statistics, because of the collaboration between science and statistics. Any questions on that idea? So you have to be real careful about just using statistics to establish cause and effect. You can't do that. You just use it to give people a heads up to say, can you see if there's cause and effect? And then the scientists go check. Any questions on that? Okay, very important piece. Okay, I thought we would do one. So I actually come up with the regression analysis. And I thought for a while to try and think of a good one. So I don't know if you'll think this is good or not, but I'm going to try it. So I have 2 questions for you. And by the way, you have to put this in the chat box because I need data. Okay. And hopefully it's nothing that's personal. If it is, you can lie, but hopefully you don't need to. Okay. So I have 2 questions. The first question is, how many apps have you put on your smartphone? So if you bought the smartphone and it had an app, that one doesn't count. But if you downloaded an app, whether you paid or didn't pay, I don't care. How many apps have you put on your smartphone is the first question. And the second question is, how many books have you read? I'm going to write by choice. Okay, so for example, our statistics book doesn't count because I kind of tell you to read that. Okay, so that might be, a kind of a fun literature book or something like that in the last year, in the last 12 months. And I want you to put in the chat box the answer to those 2 questions. Maybe write the first answer, comma, the second answer. So 8:15. Keep going. I need more. $31, 12, 20, 12:20.
Hey, Larry, in the last 12 months, does that pertain to the smartphone apps as well, or just?
No, total smart on your phone.
Okay.
So whatever, however long you have your, maybe I should say in the last 12 months. That's probably better. That's a good question. But since you've already put the numbers in, I probably shouldn't change it.
Yeah, no, it's
10:13.
It's fine.
Okay. All right. Now we don't have a lot. Brawley, did you put yours into? I need as many data points as I can get. 0, 12. 22. Okay. And maybe I'll put mine in too. I'll put it in the chat box too. So I have put 3 apps on my phone. And in terms of books read, I'm going to say 7. Looks like I'm busier than most of you. I don't have low numbers for both. Again, I'm not in your classification, your students, and I'm busy. I don't know. Okay, so that's what I've got. Now what we want to do is the following. The first thing we're going to do is say, is there a correlation? So when you're asking something like, is something happening, given the last 4 or 5 weeks of class, What do we need to do in a couple words? So if we want to find it, is there a correlation between the two? Yeah, exactly. Hypothesis test. I like that you did all in caps because we should be screaming hypothesis test because that's what this class has been all about in the last half of the class. So we're gonna do a hypothesis test. So the good news is that a hypothesis test for correlation in this class will always have exactly the same H naught and exactly the same H1. So H naught, colon, hopefully you know it always starts that way. Now, here's a tough question. Who knows the Greek letter for R? That's a tough question. It's not a math question. It's a Greek question. I should ask, anyone speak Greek here? Never had anyone say yes in my class. One of these years. Okay, anyone know the Greek letter for R? Okay, so let me show it to you. It's this guy. It's not a P. Can you remember the word? Can you remember row, row, row your boat? Remember that song? So the way you pronounce this letter is rho. So that's the Greek letter for R, and it's rho. Unfortunately, it looks like a P, but it's not a P. It's kind of a curvy P. Equals 0. And what that means is the population correlation equals 0, because all we have is a sample correlation. And then we have H1. And that is going to be rho is, and in our class, I'm going to only have you do detailed tests. Okay, at least for the final exam, I guarantee that you're going to be asked a two-tailed test for the correlation. So I'm going to stick with that. There might be a homework problem or two where it's one tail. And that would be if you think the correlation is positive, then it'd be greater than, or negative be less than. But for the final exam, guaranteed it's going to be a not equal to 0. Any questions on the correlation, the hypothesis test? Any questions? Okay, so the next thing I need to do, and hopefully used to this, any guess? Yeah, get the p-value, and how am I going to get the p-value?
We need to put the data into a calculator.
Exactly. So I can go to the calculator. And here's some good news, by the way. Any guess on what calculator number it is? Yeah, it's 24. So it's calculator number 24. And if you look at the list, there's only one more. And that's next week, by the way. And that's a short one, by the way. So we don't have much left in this class. We're almost done. So we can see we're 25ths of the way done with the class. So I'm going to hit regression analysis. And the way I program this is kind of a little different than some of the others because I wanted to visualize things. Is I asked you for the points. You put the point in. So the first point was 815. So 815. And you hit plot point. And it plots the point. And then you put the next point, which was 3112. And you hit plot point. Okay, so by the way, if you only have 1 point, you can't do a line. Doesn't even make sense. But 2 points, we have a line. By the way, what do you think the correlation is going to be if you only have 2 points? Or even better, what do you think R squared is going to be? Any thoughts? The hint is it's obvious. What do you think R squared will be? How far away are these points from the line? Take a look. I don't see y'all jumping in. You see, they're on the line. Yeah, they're on the line. So if they're perfectly on the line, R squared is 1. That's as good as you get, right? Any questions on that idea? So by the way, over here, you'll see R squared equals 1. You'll see that we have there's no test statistic in p-value when you only have 2 points. Not enough points yet. So let's get another point. And that's 1220 was the next point. Plot point. And all of a sudden, they're not all on the same line anymore. Okay. So now all of a sudden, our R squared just dropped big time. And that happens. So let's do the next one, which is 1013. And hit plot point. Okay, and you can see it doesn't look like a great fit. Again, I had no idea when I did this because I didn't know what you guys were going to say. So notice our R squared is now 0.22 or so. Our R is negative 0.467. Notice that the slope of the regression line is negative, R is negative. So R and the slope of the regression line always have the same sign. Okay, so let's do another one. 012. And let's see what we get. Okay, and let's do some more. 2012. Sorry, 22. Plot point. And then the last one was me, 37. Plot point. Okay, so what do you notice? First thing, notice the equation of the regression line is about 12.4 minus 0.0731x. Okay, so 12.4 would be our best guess or our best prediction for someone who has put 0 apps on their smartphone. So it's the best prediction for the number of books someone who has read who hasn't put any apps on their smartphone. Whereas negative 0.07, you could write that as negative 0.07 over 1. So we could say that for every app someone puts on their smartphone, there tends to be 0.07 fewer books read, which means it doesn't really change anything. Any questions on this idea? Okay, R is negative 0.13, which is close to 0. R squared, which is 0.02 about. So that means that only 2% of the variation in the number of books people have read can be attributed to the number of apps they put on their smartphone. Whereas the other 98% of the variation of books people have read come from other stuff and other reasons. Any questions on that idea? Okay, here's the hypothesis test. And notice that the test statistic, it just nicely is actually a t statistic. I'm not going to go over the math, but you can trust me that it's actually the same mathematics as the t-test. So you don't need to know that, but it is. but the p-value is 0.77. What does that tell us?
We're gonna fail to reject.
Yeah, in a big way, right? It's not even
Yes.
close. Okay, so our p-value is 0.77. Let me write that in. In this case is 0.77. So that means we fail to reject. So there is, and hopefully you're used to this, statistically insignificant evidence to conclude that there is a correlation between number of apps people have put on their smartphone and the number of books they have read by choice in the past 12 months. Any questions? Any questions on this interpretation or this conclusion based on the p-value? Any questions on this? Okay, just a couple of notes. Okay, especially when it's severe like this. If we really fail to reject, what that means is that you shouldn't even use this regression line. Okay, it just means that you should not even try to use a number of apps people have put on their smartphone to predict how many books they've read. Any questions on that idea? Okay, so this is one of those where there's no evidence that there's a correlation and it's not even close. We're at 0.77. You know, if you're at 0.07, you might say, well, maybe you can still do it, but here you can't do it. So you don't even use the regression line to make a prediction. And you say, well, maybe other things are better predictors. Maybe age is a better predictor of how many books people have read. I don't know. Okay. Any questions on this idea? Any questions on regression analysis?
Yes, can you go, can you show where you got the R from again, please, so that I can write down the note?
Oh, it was just right there.
No, I mean on when we were doing the lake, or do you want us to, are we
Oh, that
okay
was
just
okay.
using
So
the
that was a
calculator?
visualized. So let me show you. Okay. So in that case, we didn't use the calculator. And let me show you what I did. I looked at this diagram, right? And I said that the points are pretty close to the line. Do you agree?
Yes.
You don't even have to use your imagination at all. You could see a line, right? I could draw a line almost without thinking. I just draw it. Does that make sense?
Yeah.
And again, this is upside down. So that slope is negative. Is that okay?
Yeah, I understand that.
Yeah. The slope is negative. That means R must be negative, right? And R must be pretty close to -1. But we know R is
Okay.
not exactly -1 because not all the points are exactly on a line. Is that clear?
Yep.
Let me give you an example where R is exactly 1. What if I asked you, how tall are you in inches as the first question, and how tall are you in centimeters as the second question? Why would R be 1?
Because it's the same thing.
Inches and centimeters aren't the same thing.
I mean, it equals, it's gonna be on the same height chart, right? Centimeters and inches.
Yeah, because there's a mathematical linear equation that tells you how to convert inches to centimeters. Right? Actually, I don't have it in my head, but I know there is one. Okay. Same thing if I asked you what the temperature in Fahrenheit was and the temperature in centigrade. That would be a correlation of 1. right? Because that's what 9/5 x plus 32, okay, is the formula. So there's a linear equation. I think that's what it is. If it's not, don't quote me. But if there's a linear equation that relates one to the other, then R will be 1 or -1, period. Is that clear?
Okay, yes.
If there isn't, you're pretty much never going to get 1 or -1 because there's always going to be some kind of noise.
Okay, so we just picked 0.9 on this, or the negative R, but if we were to know exactly where those plots landed, we could stick them in your calculator and get the R to the exact, right?
Right, the calculator. And also my spreadsheet program does it too. If you have a whole lot of points, the spreadsheet program is actually a lot easier. And there's a tab for regression analysis, and it's easy. Just let you know that. But for the final exam, because I embed the calculator in, the spreadsheet's too big to embed it into the final. So that's why I created this calculator for you, so that it fits in the final nicely and the rest of the test. So yeah, so you can use the calculator, with the data. Okay, and of course the UC Davis people use the calculator. They didn't eyeball it. But what I want you to do is kind of be able to get the idea of eyeballing. And if you gave me 0.8, that'd be fine. -0.8, that'd be fine.
Okay.
Okay. But if you give me -0.1, that's not fine. Because -0.1
right,
is like the night sky. Do you see?
Yeah. And then on the homework, we will have the plots to put in the calculator.
I think so. I'm pretty sure.
Eyeballing.
Yeah. I know I wrote all the homework problems and coded them all, but I'm pretty sure I put them all without eyeballing. But you should know how to eyeball it. I could ask you on the final to eyeball something. I've done that before.
Yeah, there's
I could also ask you to do with data. But good question.
So there's like 1 or 2 eyeballing questions, and then there's another question that asks you to input data. I'm not sure if the calculator allows you to erase incorrect points, so just be careful.
Yeah, the calculator is kind of awkward. So on the final, I'm not going to give you that many points to put in. So it won't destroy you. But the spreadsheet does. The spreadsheet's actually easier. Maybe I'll even go to that, so I'll show you how easy that is. You could actually copy and paste in the spreadsheet if you want. It takes forever to get there, though. I have to go here and here. No, here. There it is. And here and here. Almost there. I think I have to do this. Here we go. You hit regression, and then you just put in your numbers.
Okay.
So our numbers were 8, 3, 12, 10, 0, 23. And our Ys were 15, 12, 20, 13. 12, 2, 7. And it gives the R squared. Just a note, and this is standard, it's A plus BX, not MX plus B. And it's not because I'm being evil. There's a reason why it's standard, but the math is too hard to explain that they use A and B. Okay, so there we go. Any questions on this idea? So again, the spreadsheet will do it also. Okay, I think we're about done. So let me stop the share. And I'm going to stop the recording. But I want to remind you, next week, strongly suggest,
Larry.
And if you could attend live, that's great, because that's going to be the review for the final exam. We'll also do part of chapter 13, which is short, and then a lot of review for the final.
Larry, the secret word. Yeah.
Oh, thanks. Thanks for reminding me. Good. I haven't stopped the recording yet. Good. Thank you so much. Let me go back to share screen.
Heather was on it too.
Let me grab it. It is.
We're in the final stretch. Every point will count.
Huh?
I
Oh,
said we're
secret
in
words
the
are
final
much-
stretch.
No, secret word is more than every point. It's a big penalty if not do the secret word quiz. You lose like a huge percent. So the secret word for this week is predicted, because you never say it will happen or it caused it. You predict that it'll be this value. So predicted is the secret word for this week. So thanks for reminding me. So now I can stop the share. And now I can stop the recording.